Hello guys, a very good morning to one and all present here. I'm Niladhar Abhijit Shetty, representing AthrV-Ed, and I've been a part of AthrV-Ed since the past 1 year. I'm doing mechanical engineering. I'll be the presenter for the day, and as a part of the entire AthrV-Ed family, I welcome you all to this session of Machine Design for All. So without any further ado, let's head straight into this session and get to know what exactly machine design is, and let's start to learn what exactly machine design is. So we'll be having a short presentation of about 5 minutes, and then moving on, we'll be directly showing you the interface of the software, and we'll be working directly with the software too. So let's not waste any further time. I'll just present my screen onto the presentation, then we are good to go, we can get started. Let's begin with the session straight away. This is a machine design live session that we have presented to you by AthrV-Ed. So starting up, you might have already heard about machine design, what machine design is. Some of you might be knowing what exactly it is. You might have already worked with some machine design softwares, while there may be a lot of others who are not knowing what machine design is, what does it do, and all those things. So we'll keep this basic session in such a way that it's applicable for everyone, the people who have already worked on the software or people who don't have any idea on what the software is. So starting up, what machine design actually is. So when we first tell the term machine design, so a rough idea that will get on your mind is that, oh, machine design is something related to designing cars or maybe designing vehicles. Oh, that may be machine design. But is that all? So machine design is just not designing cars or designing bikes or designing airplanes. It's the application of a vast majority of engineering concepts, maybe mathematics, kinematics, thermodynamics, mechanics of materials, and a whole lot of others. You apply all these things onto the mechanical components that design a particular tool, maybe a particular model, maybe a car, a screwdriver, a spanner, a mobile phone, or any particular component. You design it using all the mechanical elements that are present in this entire universe. That is machine designing. And one of the most important parts of machine designing is machine drawing. So what exactly is machine drawing? So you might know that whenever you design a particular product or design anything, you will design it on paper. The same way, what we do in machine designing is that we use a software. So we use a software, we design a particular 3D model or a 3D part, and then we manufacture it. In order to manufacture, the manufacturer won't be able to access the laptops, or you won't be understanding the all the complex 3D things that you have done. So what you'll do is you'll convert your 3D design into a 2D drawing. That is nothing but machine drawing. So we'll learn all about these in the further examples that we're going to see. So this is just a basic intro. So to know more about what machine design is, let's consider a simple example of a gearbox. So if you know, a gearbox is something that will transmit power and motion of the engine onto the wheels. So if you consider a gearbox, there's an engine, there's a wheel, there's a steering system. So there are 4 major components that are being used over here. But there are very small, tiny parts inside these major components, maybe small screws, small grooves, small gears, and a lot of things. In order to design a perfectly working car, you need to lay all these things properly. So there should be a proper assembly of all these things. Only then your machine will run or your car will run. So how exactly will you know that each of these things are working together hand in hand? So that's when machine design comes into play. So you design each and every single part, you assemble each and every single part, put them all together, test in your software whether it's working fine or not, and then you head on to the manufacturing process. So that's how machine designing is widely used in the entire world. Moving on, let's get to know some of the applications of machine design. So like you already guessed, machine design is something that's being used mainly in the automobile industry, in the aerospace and defense industries, mainly in tools and equipment manufacturing. Whatever tools that you can see in and around you, maybe a laptop, maybe a screwdriver, scissors, robots, complex mechanical instruments, all these things are done with the help of a machine design software. The first step to a manufacturing process is design, especially in the manufacturing of a mechanical tool or an equipment. Next up, we have industrial production, and one of the main booming industries these days is mechanical/structural analysis. There may be a lot of people who design stuff. An artist might design a car. Someone like a 4-year-old kid or a 6th standard science student can design a car. But there is someone who analyzes if your design is perfect, if your materials that you have designed is perfect. So that's also a part of machine designing, which comes in the advanced module, that is nothing but structural analysis or material analysis or aerodynamic simulations. So all these things are also a part of machine designing. Moving further ahead, let's just rewind to the era before the machine design software. So how exactly was the entire universe working before the usage of machine design softwares? So what used to happen, like you already know, when you were a kid, there will be most among us who are passionate to draw cars, just see auto cars, see a very good model, then sketch it on paper. Since design a Lamborghini, design a BMW, design an Audi, this used to be the passion for most of us. But before softwares, this was exactly the same thing that was being used in the entire world to design a particular machine. Not just cars, maybe any simple tool that you had to design, you were following the same process. So there would be a designer who would design his creativity, his imagination, his knowledge, using his knowledge of mechanical properties, of aerodynamic properties, he used to design something on paper. And this particular drawing or design would then go on to a modeler. So there would be a guy called as modeler who would model all these entities using wood or using wax or using any other particular material. So if at all you model and then you have to make a small minor change. For example, let's say you're designing a car and you are a designer and you design a car with the wheel of say 16 inch, and then you give it to the modeler and he designs the exact same model. Then right up you change your mind and you say that I want the wheel to be 17 inches. So what does the modeler do? He needs to design the entire thing over and over again. So for every single iteration, there have to be multiple models done. So this was the era before software actually existed. So if you see the slides over here, you can see that the rightmost image is that of a General Motors car that is being carved out of wood just to see how the design would look like. The first drawing that you can see is actually one of the most initial models of a Lamborghini. The second one is a Cadillac design that is made of wax. So all these things were used before the era of softwares. So moving quickly ahead, before analysis, what were the people exactly doing? So you design a model, then you need to analyze it. You need to know whether you can fit your engine onto there, whether you can fit 4 people onto that. So you need to know all these things. So they used to analyze, they used to perform load tests, they used to perform aerodynamic tests, and a lot of others. So what they used to do before the introduction of softwares, or before the introduction of simulations or aerodynamic analysis, or before the introduction of these softwares. So one of the most crucial things that were followed during these days was you design a car, you manufacture it, you bring it product ready, and then what you should do is you should stick tapes on the side, or you should stick threads or strings onto the side and then run the vehicle. So once the vehicle runs, depending on how the string moves in the air, that's the way how they used to analyze cars and how they used to analyze planes. So you can see a image right down here of aeroplane wing, which has been put on, where there are various strings that are put onto the wing. So when the airplane is flying, how the air flows over the wing surface, that is being studied in this particular type of analysis. So this was a very complex method that was used before the introduction of softwares. For every single iteration, you have to remodel, you need to figure out the changes, and it used to consume a lot of time. But today, with the introduction of these machine design softwares, all these particular things, right from your design to your modeling to your assembly to the analysis, right from design to manufacturing to production, everything can be done with the help of these softwares. So these can be done very easily and will not consume more time also. So let's take a look at some of the popularly used softwares that are used around the world. One of the most important popular softwares used among the world is the Dassault Systèmes CATIA. So many of you might be familiar with this software. So this is used by leading automotive producers such as BMW, Audi, Mercedes-Benz. Many different people use CATIA. Then there's OpenFlow, free software, Autodesk Fusion 360, PTC Creo, Siemens SolidEdge. The Creo and SolidEdge, one of the most used machine design softwares in academic usage. Siemens NXCAD. Siemens NXCAD is also widely gaining popularity these days among the entire world. And Dassault Systèmes SolidWorks. So Dassault Systèmes SolidWorks is a software that we are going to learn today. We're going to have a brief intro onto this software. So why is this software mainly beneficial? Is because it has a very simple layout. It's very beginner friendly. Even though you don't know what complex mechanical terms are, even if you have not completed a mechanical degree, you can easily understand what are the things present inside the software. You can easily model, you can easily sketch, and there are various different ways. Some of the leading companies that use the Dassault Systèmes SolidWorks are Coffee Day, Tarot Drones, Asteria Aerospace, and a lot of other companies worldwide which are using Dassault Systems. Mainly, it's used by leading universities like Oxford University and Cambridge universities for their master's program. So it's a very academic-friendly software, and it's mainly used by students rather than industry professionals. So moving on, let's see a simple video on what exactly machine design is and what exactly SolidWorks does. So in the next few minutes, maybe in the next 2 minutes, we'll get to learn about what are the various things that SolidWorks as a software can do. So let's just head on to the video and watch it. So that's the power of SolidWorks. So these are various things that you just saw in the video. Those are the things that SolidWorks can do. So we saw that varying from motion design to complex assemblies to advanced surfacing to differential motions of vehicles to simple parts, everything can be done in SolidWorks. So this in the video, what we saw was just with respect to the mechanical parts, but this tiny little software can work in various ways, even into the electrical domain. Complex electrical simulations, rigging up of circuits, designing of capacitors, resistors, and various other electrical components, in the flow analysis, in the electricity analysis, how current flows through a particular circuit, and how air moves through a complex machine part. All these things can be studied using this particular software, that is SolidWorks. So what you can see on my screen right now is the welcome screen of SolidWorks Academic Edition. So what you can see is there's a part, there's an assembly, and there's a drawing. So these three things are one of the most important things that are being used in any machine design software. So you need to know what a part is, what an assembly is, and what a drawing is. So a part is nothing but a single or one of the smallest entity of an entire machine part or an entire assembly. So if I consider my human body, my hand is a part, my teeth are part, my eyes are parts, my legs are parts. So these are small parts. So once these parts are combined together, they become an assembly. So that's the same way how it works onto a tool. For example, if I consider this mobile phone, the button over here is a part, the microphone slot over here is a part. So every single part is rigged on together, and then we create an assembly. So what an assembly is nothing but a collection or a combination of individual parts. So in order to design any product, you need to have parts in it, and you need to have a complex assembly or a simple assembly. Okay, so what is drawing now? So say, for example, you're a designer and you design a part. Say, let's consider an example that you design a car. So you design a beautiful 3D car, and then you want to manufacture it. So how do you manufacture it? In order to manufacture it, you need to give your car to the manufacturer or the manufacturing plant. So these people who are at these manufacturing factories, they won't be able to understand the 3D models. So what you give them is a blueprint or a 2D drawing. So whatever 3D things that you have converted is straight away converted into a 2D drawing. So this is why drawings will come into use. So let's just head on to the software and see how the software actually works. So to begin a simple part, you just click on part. So once you click on part, the software will load and it will open up a sketching window for you where you can sketch various different things. So like I already told you, in order to get a simple sketch, what people used to do before the evolution of softwares was they used to design on their hand on paper and then give it to a modeler. That's the same exact principle that's being followed in these softwares too, but the process is very easy and very simple. Okay, so what you need to do is you need to design a sketch first. Design a sketch is nothing but the same way how you design a car on a paper, the same way you need to design a simple 2D sketch on the software. So then the software has various features which will help you convert that particular 2D element into 3D. Okay, so let's just get to know the layout of the software. It's very basic, can be understood very easily. So starting up here, there's a small window that will let you know what exactly you're doing. For example, now it's showing me editing part. So that will show you what exactly you are working on the software, so that even the user can know what exactly he is doing. Then there's something called as MMGS. So whatever you're doing in machine design has to be defined, and you define it based on measurements. Say for example, I had to design this phone again. So I can't just randomly draw squares and design it. I need to give the measurements, how lengthy it is, what is the width of the plane, what's the height of the phone. So all these things have to be given. So whenever I say measurements, there's some unit that has to be associated with that particular measurement. So this software, since it's being used worldwide, has various different units that can be used. The most common one is nothing but the millimeter gram second. That's the ideally used unit. If at all your school, college, or workspace is using centimeters or meters or inch, you can just right away change it here by just a click of a button. Then all your measurements will come into that particular unit. So what you can see down here is a feature manager or a feature tree. The feature tree is nothing but it will show a list of all the different things that you're going to do in a software. For example, if you're doing a simple 2D sketch, it will show you the 2D sketch over here. If you're doing a complex assembly, that will show the complex assembly over here. So this is nothing but a map to everything that you're doing, right from the first thing that you start onto your sketch until the final assembly. Everything that you do will be displayed over here. This is the feature tree or feature manager. So let's get to know about this in a little while later. So up above here, you can see various little tabs that are being placed in the software. So what do these tabs exactly do? Since I already told, it's a very user-friendly software. So, and we also saw what are the various different things that the software can do. So every little thing of these is being classified differently. So if I see this features tab over here, what does a feature exactly mean? A feature is nothing but a three-dimensional entity. So whenever I have been using the words 3D, 3D, 3D a lot of times. So how does your model get life, or how does it become three-dimensional? That is using this features tab. So we'll learn a little basic about these features tab a little time later. Then this is the sketch tab. This is the thing that you use to design your sketches. There's everything from lines, circles, arcs, rectangles. Every single thing that you can see in your life is presently over there. That is like it may be a line, it may be an arc, it may be a curve, spline, everything, a polygon, a closed rectangle. All these things are over here. So this is just to define a sketch, in order to give dimensions for your sketch, in order to start sketching, in order to simply design. So that's how the sketch tab works. Next up, we saw in the video how a helmet was designed, how other things were designed. So those were nothing but surfaces. So what is a surface design? A surface is nothing but a smooth element, like we all know. So if you're designing an automobile, so you'll have the doors to be designed, you'll have the interior to be designed. So these interiors are smooth surfaces. So in order to sketch that, you can't use the 3D element. So what you will use is a 3D surface. So this surfaces tab will give you a various different tools that you can use for surfacing. So if you want to do a surface model, all you have to use is this tab. There are very few tools. So based on these, you can sketch your simple surface. Next up, we have something called a sheet metal. So if you're designing a laptop or a CPU or a DVD, so that's something that uses sheet metal. So sheet metal tab is right here, and you can do various different things like a sheet metal in the sheet metal tab. So what the sheet metal tab exactly does is, if you consider a pizza box, when you open it, it will be nothing but a plane. It will be a 2D structure. Only when you fold it and then you assemble it, it will become 3D. The same way, even in sheet metal, you have the option to convert a 2D sketch and then model it out to 3D. The evaluate tab just helps you know what exactly you're doing. It makes the usage of the software pretty much easy. So it's very easy. In the evaluate tab, you'll get to know all of these things. So these are the different add-ins that you can use. Next up, we have visualize. Visualize is something that we use for rendering. I'll tell about this at the end of the session. Next up, we have something called as analysis preparation. Analysis preparation is mainly for the analysis that you saw. So simulation of airflow over a wing. So that's the thing that you can do. So without further ado, let's move on to do a simple sketch right here. So before that, we need to know what exactly a plane is. A plane is nothing but a flat surface. Like you say, a plane is nothing but literally a flat surface. So before I started moving on to the software, I told that if you want to design any 3D element, what you have to do is you need to design a simple sketch out of it. So how do you design a sketch? We saw before the era of softwares, people used to design it on paper. The same way here, you need to design it on plane. So whenever we say 3D, this for example is a 3D element. So when I say 3D, the first thing that comes to your mind is I rotate it 360 degree, every 360 degree there's an element present, so it is 3D. Yeah, that's the right definition. But how exactly do you design a 3D structure in this software? It's pretty simple. All you need is 3 views. You need one view. Say for example, I'm designing this mobile phone. You need 3 views. One view from how the mobile phone will look when I'm seeing from the top. So I see from the top, I see a simple rectangle. That's my top view. I see it from the front. This is my front view. When I see it from the front, I can see the speaker jacks over here. So that's my front view. Then this is my side view. So when I see it from the side, how does it look? The buttons are there. So all these things, this is a basic 3 views that are required to convert any 2D sketch to a 3D sketch. So all you have to do is you need to do the top layout of this, you need to do the front layout of this, and you need to do the side layout of this. Then the software will automatically convert all of it into 3-dimensional 360-degree revolving entities. So that's basically it. So this is the front plane. That is how the view looks from the front, how it looks from the top, and how it looks from the right. So this is how the software works, how you can design in the software. So to learn about sketch tools, let's consider a simple example. Let's consider that I'm a designer and I'm working for a company called as ABC Tools. Okay, so the people at ABC Tools want me to design a simple spanner. So ABC Tools is a company that produces a lot of equipments or tools. So they want me to design a simple spanner. So they hire me a contract to design a spanner. So let's see how I can design that. So I know how a spanner looks. So what I'll consider is how the spanner looks from the top. So first up, I'll select my top plane because I know how my spanner looks from the top. I'm not exactly sure how it looks from the side and how it looks from the front, but I'm pretty sure how it looks exactly from the top. So I'll go on to the top plane. I'll just click on top plane. When I click on top plane, there are 4 icons that are being shown. So the first icon is sketch. The second is show, the third is zoom, and the fourth is normal. So what we'll be using is sketch. So this is nothing but I'm choosing a top plane. That is nothing but it's like choosing a paper. Then when I choose to sketch, it becomes normal. The same way how you place a paper on top of your table, the same way your plane comes onto the normal view. So now what you have to do is you need to just start sketching. So what I'll do is I'll take the line tool. The tool over here is a line tool. I'll just put 2 basic lines. So if you can see, when I move my mouse, there's a yellow color spot appearing and there's a one single line that appears on top of that yellow rectangular block. So this indicates that my line is perfectly horizontal. So if you're sketching on paper, to make a line horizontal, what you're supposed to use is you're supposed to use a scale and then draw. Sometimes even while using a scale, you might get a line that is maybe slightly slanted or maybe at a different angle. But when you're using a software, you can get a perfectly horizontal line. So this is how you can get a horizontal line. So what I'll do is I'll sketch 2 lines. Now I want my line to be parallel. So if I just move my mouse without clicking below this point, it will show me a line. That line shows that the starting of the starting point of the second line and the starting point of the first line are parallel. Even this line, I want it to be completely horizontal. So I'll just move down. Now we can see that there's a yellow color rectangle appearing and it says as horizontal. Then there's a vertical line appearing. The vertical line appearing says that these 2 lines are parallel together. Okay. So this is how we can draw a simple line. Next up, whatever simple sketches that you do in any machine design software, what you do is you need to define it. How do you define it? You define it using smart dimensions. That is nothing but you give it a dimension. If you have to design anything on paper, say for example, you have to design a rectangle on paper. So what will you do? You take your scale, you design a rectangle. You will have something called as dimensions. For example, you want a rectangle of 6 cm cross 2 cm. You will draw a 6 cm horizontal line and 2 cm vertical line. The same way, we can draw the lines first and then give the dimension. You can draw your entire sketch first and then also you can give the dimensions. So that's one of the major advantages of these softwares. Before that, I'll make these 2 lines equal and I'll make them parallel. So you just click on both these lines, you'll get a window over here and you'll get it as equal. So if I change the dimension of one line, the second line automatically adjusts itself to that line. So now I want my line to be 120 mm. So both these lines are 120 mm. So now I want the width between these lines to be 40. So I'll make it 40. And now I want it to be placed exactly to the center. So this point that I can see over here is my origin, or you can consider it to be the center of your plane. As you know, plane is something that is infinitely available. So it's like a sheet of paper that is infinitely long. So this is the origin, that is the exact middle point of my plane. So what I want is, I want my two lines to come in the exact center. So what I'll do, the entire length is 40. If I want it to be centered, I'll give this distance as 20. Now you can see that these planes are in the exact center. Since this is 120, I also want it to be horizontally centered. So I'll give it 60. Now you can see that the entire setup is centered about this point. Okay, so as I already told, I've been designing this spanner. So I'll design a very simple spanner. This might not be very accurate, but just to show the basics of how the software works, how the sketch tools are working, I'll design a very simple one. This might not even be an actual spanner. So I'll just show you how it can be done. So now I wanted two circles. So what I can do is I'll just click on the circle tool that's present over here, and then I draw a circle. When I drew the circle, I want my circle to come out at these points. So what I did was I'll show that to you again. I just click on circle, and I want it to start from the midpoint. So it is showing me a horizontal line and a vertical line. That indicates that I'm at the exact midpoint. I start my circle center from there, and I want it to touch both these lines. So when I click down here, the line becomes orange, and there is a symbol of tangent that's being shown down below. So this is one of the most easiest things that the software does to you. It gives all the relations very easily. So there has to be some study done about relations, but I'll just show you how the software is very effective in doing all these things. So I'll design a simple circle likewise, and the same way I can design another circle over here. So now what I want is, I'll design the cut of my spanner. The spanner should be a cut surface. So I'll design a cut over here. So I'll select my line tool. I'll just design a simple shape like this. Let us consider it to be like this. A simple, very simple shape. And let us make it a little bit bigger. Simple shape. Okay, now there are some unwanted elements. These are the unwanted elements of my sketch. So there's a concept called as trim entity. So if I select on trim, and then if I just drag over these unwanted elements, those elements will just disappear or get erased. So these are the very beautiful advantages of this software. So now I have a basic simple spanner that I've designed. Now, if you can see, these edges are very sharp. So I want to round those edges off or make them a little bit smooth. So I'll use a tool called as fillet. So fillet is one of the sketch tools. I'll just select these two. Now my edges are a pretty little too big. So I'll just select the dimension again. I'll just put it as 2. I'll get a small edge. So that's basically it. Now what I feel is I need one more hole extrusion over here. So I need since every spanner is a double-sided spanner, so I want to make it a double-sided spanner too. So what I'll do is I'll click on the pentagon tool or a polygon tool, and I'll make a simple pentagon. So since a pentagon has 5 sides, I'll click on 5. I'll do a simple pentagon over here. So this will be my pentagon. And then I'll again round the corners of the pentagon. I can zoom in and see the corners are pretty sharp. Just round them off by clicking the fillet tool and clicking OK. So this is how very easily you can do the rounding off. Then if you see, the spanner won't be abruptly sharp in this position. So there will be a little bit of curve in that. So what I'll do is again click onto the fillet tool and click these edges. Now I want my edges to be a little bit more smooth. So I'll give a bigger dimension, say 25. Now this is my simple sketch. So now I'll just click on OK and exit my sketch. So I've done sketching. So this is my 2D sketch. Now what I have to do is I have to convert this 2D element into a 3D. If I just rotate it 360 degrees, you can see that it is just basically on one single plane. It's just a simple drawing. Now the thing is to convert this into 3D. So what I'll do is I'll select the sketch. I'll click on extrude, go to features. Like I already told, feature is something that converts 2D to 3D. I'll go to features, click on extrude. So this will add thickness to my spanner. You can see that my spanner is getting some thickness. So the software will automatically show you the preview so that you can get to know how exactly thick your spanner will be. So this is a little too thick. What I do is I'll just reduce it and make it around 7 mm. So 7 mm or 0.7 centimeters. So this is pretty much it. So this is my spanner. So now what I feel is if I just zoom into this, these edges are also again sharp. So now I need to do a fillet again. So instead of doing a fillet sketch, I'll do a fillet in the entire 3D structure. So since this is already converted to 3D, I'll go into my features tab. There's a fillet over here. I'll click on to fillet. I'll click on the edge and I'll reduce the radius to say 2 mm. I'll just make the front and the rear a little bit smooth. So you can see now that this is very much smooth. Now, if I feel that I need to give a small cut over here just to write my company's name or just to make a holding grip, so what I can do is I can sketch on top of a 3D element too. I've told that in order to sketch, you need to have a plane. A plane is nothing but a flat surface. The top of my spanner is a flat surface. So I can sketch on that. So how do you sketch? Just click on that flat surface. There's an icon for sketch that is nothing but a drawing tool, like a drawing sheet kind of thing. Just click on that. And I'll draw a simple rectangle. So this is a rectangle tool. I'll select the rectangle tool. I'll draw a simple rectangle. So this is my rectangle. I want this to be cut. So I'll go to my features window again. I'll give an extruded cut. And I want this to be very little, maybe just around 2 mm. So I'll click on OK. You can see over here, the software is showing you a preview how much it is getting cut. So this is my basic simple cut. And this is my simple spanner that I've designed for ABC tools. So now, like I already told, when you design something, you need to give it for manufacturing. So when you give it to the manufacturer, you need to add something called as a material. So the manufacturer won't know what material it is to be added. So all this thing is done by a designer. You being a designer will add a specific material, you will analyze it for different loads and then design the final product. So now I need to add a material to this. So I'll click on materials, I'll just right click it, and since it's a spanner, I'll just give it to be cast iron. So once I give it cast iron, you can see that from gray, it has changed to a cast iron color. So this is how you add the materials. So when I give this spanner to any guy who is manufacturing and I convert it to a 2D drawing, he'll also know that the material used in the spanner is cast iron. So what he'll do, he'll choose a cast iron and then he'll start producing the spanner. Okay, so this is how the process of designing works. There's one guy who's designing, another guy who is manufacturing. But in the beginning, I told you that I've been given a contract by ABC Tools. Now, the manager who is working at ABC Tools might not be a mechanical guy. He might be a commerce guy or an MBA guy. So he needs to know how my product actually is. So he'll not know any mechanical entities, but he'll know only the visual entities. He'll know how good my spanner is, how attractive my spanner is. So in order to do all these things, SolidWorks also offers a particular tool called as a visualize renderer. So what the visualize renderer does, so this visualize renderer assumes that you have already performed or manufactured your model, and then it will click the real life image of that particular model. So it will give you a photorealistic image. So let's see how you can do that. So before that, I need to just go to file and save my file. Just click on save as, and I'll just save my files over here. I'll just save my file. And then, as I told you, there's a tab called as SolidWorks Visualize. This is the tab that we use for rendering. I told it in the beginning. I just click on Export Simple. So when I click on Export Simple, the SolidWorks Visualize software opens up and a new project is being created. So whatever model that I've created over there is now visible in Visualize. So if I just zoom in and if you check now, you can actually see a cast iron kind of material that's been put up into this. So if you see my SolidWorks file, there is nothing. It's just a plain color. There's nothing else. But if you see the Visualize file, you can see there's an actual material that's being put up that is cast iron. So now what I have to do is I have to render this out. So once I render it, it will give me a photorealistic image that I can visually show to my clients or visually show to anyone, maybe your parents or maybe someone who is actually interested in design. You can show them these, and then you can see that this will be the final, this is how the final product will actually look like. So that's how you do the rendering. So there's an output tool called as render over here, and then you just click on render and it gets rendered. Since the rendering tool uses graphics processor, it will take up a little bit more time than we have for the session. So what I've done is I've already pre-rendered the images a little while ago. So what I can do is I can just show you the rendered images, and you can have a look at how exactly it will look like. So these are the rendered images. So this is how it will look with the cast iron material applied. So this exactly looks like a spanner that has been modified, and it's a photorealistic image of the material cast iron put into my spanner. So this is how, when I decided that I want my spanner to come into stainless steel or any other steel alloy. So I just changed my material to steel, and this is the output of my render. So you can see how the software automatically clicks an image that is very photorealistic. This was a basic render that I have done. What you can do is you can change the backgrounds. You can keep it an industry background, keep it a manufacturing background, keep it a workshop background, or do it in any way. Keep a table underneath it, and you can modify in various different ways. This is one of the most basic renders that I've done, and you can see the result is like it's a very high definition image, and it's very photorealistic. Then now I decided that I changed my alloy, and let me see, I put a pinkish red aluminum alloy. How will my spanner look? So when I do that, I get this render. So if I show this to my client will be pretty much impressed, saying that, oh, this is a final product. Just by seeing the final product, he might be able to pitch in on me and then give me the contract of designing the same. So these are the various different things that the software can do. So that's pretty much the entire session for us today. So we saw how we can do a simple basic sketch in SolidWorks, how we can do a render, and all those things. The software also has an integrated cost calculating software. So if you just put up cast iron there, it will calculate the entire cost that is required to do your entire project and all those things. So this is pretty much the basic things that you can do in the software. So that's the basic session that we had for the entire day. We saw what SolidWorks is, how you can work on SolidWorks, what's the render, and all those things. So, and one more thing, when most of the people registered for the event, a few of them have asked about the certification program, about whether there'll be certificates provided for the session. So we responded a few of them saying that it's not just certificates, but there's pretty much greater to achieve in this tool. So what exactly you'll be getting? So I'll give you a simple example. You go to college. The college doesn't give you a degree certificate just for attending their classes. So this was just like a learning session. So in order to get a certificate or get a degree, you need to write an exam. The same way, what we'll have is we'll have a design challenge. So we'll put up a design challenge that's open to all. You can learn the software, you can come up with your own designs, then you can come up with a design on your own. There'll be a design competition amongst all people, and then we'll analyze the designs, and then we'll give you cash prizes based on these designs and certifications based on this design challenge. So to get to know more about the design challenge, when it will be held, how it will be held, just ping us on our social media handles or follow us on Instagram, LinkedIn, or Facebook, and just stay tuned for these design challenges. So we are almost 40 minutes into the session. So we'll have a bit Q&A session. So there are some, if anyone has any questions to be asked or any doubts regarding the software or anything that you would like to know, you can just unmute yourself and ask a question.
Good morning, sir.
Yeah, good morning.
Sir, I have do you have any online courses regarding machine learning?
Online courses in the sense, what you're planning to do is the same way how we had, was your question for machine learning or machine design?
Machine learning, machine design, same thing.
Okay, machine design. So machine learning is something that we use in artificial intelligence. So whatever we do over here is machine design. So just don't get confused. So this is machine design. So online courses that you asked about, we at AthrV-Ed, what we're planning is to have more live sessions like this. So this was a basic session. So in the next few weeks to come, we'll have more intermediate sessions or more sessions like these. And if at all everyone is agreeing, or we can even have a session wherein we give you the software. And when I sketch parallelly, even you can design on your own, right? In your own laptops, you can design the same thing what I'm sketching over here. So that is what's being planned. So based on the responses, we'll definitely plan on for it. So we don't have any online classes right now or online sessions. So this will be the knowledge sharing sessions that we'll be having every now and then. So just stay tuned on our social media accounts for more.
Thank you, sir. Thank you, sir.
So SolidWorks is a paid software. Is there like a license for us to get it for a free period of time?
Yeah, like you already told, SolidWorks is a paid software, but SolidWorks offers an academic license. So academic license is something that you can get if you're a student group, or if you're working on any particular project, or if you're working on, say, any particular paper or research paper, or working on any team. So then you can get the academic license, which will be valid for around 1 year. So you'll get a 1 year license if you're a student.
So do we have a license currently, our college?
Our college doesn't have, but we at AthrV-Ed have a license.
Okay.
I'm not sure about our college. I'm not sure if they have the license or not, but we at AthrV-Ed have a license for it.
Can the software be used online or offline?
This software, since we already saw that there are various different things done on the software, maybe electrical, maybe mechanical, and a lot of things. So this is mainly an offline rendering software, but machine design is something that you can do it online also. But SolidWorks is mainly offline. Everything.
No, in Fusion 360 we'll have that same feature. We can use it offline, but for saving or any other modifications, we'll have to do it online. So is that similar to this, or?
No, this software is completely offline. You need not even be connected to the internet to work on this. It's completely an offline software. But there's an online community by SolidWorks, so you can post your designs online. But there's nothing like online working or online rendering. Everything is offline.
Okay.
Good morning, sir.
Yeah, good morning, Darshan.
Sir, what is the difference between CATIA software and SolidWorks, sir? Because I am learning CATIA now, sir.
Okay, so what's
SolidWorks is better one or CATIA?
See, to answer your question on what's the difference between CATIA and SolidWorks, both are machine designing software. So there's not much of a difference between CATIA and SolidWorks. The thing with SolidWorks is that it's user-friendly. All the tabs, like you saw, is very much user-friendly. It's very much detailed. You can see what exactly you're doing. But whereas in CATIA, all the tools, all the icons are pretty much a little bit complicated. Not exactly complicated, but it's not very user-friendly. And to suggest you on which is a better software, I can't do that, because both the softwares are working on machine designing, and it's about how you learn one particular software. So one major myth that most of the engineers have is that to learn multiple machine design softwares. That's not exactly the case. So what you need to do is you need to master one particular software. Instead of becoming a jack of all trades, just choose one particular software on your own. It may be a user-friendly software. It may be a very advanced software. Just choose one, become a master in that. And if you get placed as a designer, and if your particular company uses some other different software, it will just take you around 3 or 4 days to learn the interface of that software. All these machine designing softwares work in a similar way, only the interface is different. So to give you more insight, it's like using an Android phone and using an iOS phone. They perform the same functions, but the interface is different. That's the same way with SolidWorks and CATIA. SolidWorks is beginner friendly, whereas CATIA is advanced. It's used mainly in industries. So that's the only difference.
Okay, sir. Thank you.
Thank you, Darshan. Okay, there's been a question put up in the chat box. It's saying that what's the minimum system requirements for the software? The minimum system requirement as prescribed by SolidWorks is 8 GB RAM with maybe 1 or 2 GB of graphic card. But the software works well and fine with the 4 GB system, but you might face some issues with lagging or due to rendering. But you can design simple models and simple sketches. For rendering, you require a minimum of 8 GB of RAM and 2 GB of graphics. Yeah, anyone else has any other questions? So there's a small feedback form that's been put up in the chat box. So just take around it will just take around 2 minutes of your time. So we just want to know how you felt about the session and how we can improve. So this will benefit you and will benefit us also. Your feedback matters a lot to us. So just take 2 minutes of your time and fill out the feedback form so that we can come up with better sessions in the coming future. Also, there have been social media links to our networks that has been put up there. So you can follow us on Facebook, follow us on Instagram, connect with us on LinkedIn, and stay tuned, because like we already told, there's pretty much big coming into store, because we are hosting an online design challenge for everyone. So it's a very good opportunity for you. It'll be very much helpful. You can learn most of the things that is being done in the software. You can improve your skill sets. They'll be very much beneficial. So stay tuned on our social media handles for more info. So I can answer one more question. It's already 50 minutes. So if anyone has one question, I can answer it for you.
Sir, can we get your contact details for further queries?
You can just drop any mail with respect to anything at ops@athrv-ed.com. I'll put it on the chat box. You can drop a query to ops@athrv-ed.com. You can drop a mail to that. Any one of us will certainly get in touch with you, will help you with the best things possible.
Okay, sure, sir. Sure.
Yeah. So with this, we'll conclude the session. The feedback form also has. Okay. So this Kaushik. Hello, Kaushik. You have a question?
Yeah.
Yeah.
It is a software widely used in industries and manufacturing sectors.
Sorry, can you just repeat your question? I didn't get your question from you.
It is a software used in industries and manufacturing sectors widely.
Yeah, the software is pretty much widely used in industries and manufacturing sector, because it's a machine design software and it's mechanically and electrically oriented. So it's mainly used in the automotive sectors or aerospace industries or in manufacturing sectors. It's very widely used.
Okay, thank you.
Thank you. Yeah. So that will be the last question. We'll conclude the session right over here. So just take time to fill in the feedback form. If at all you have any further questions, there's a slot given in the feedback form to put up your questions also. So you can put it there, or in any further, you can just drop a mail to us at ops@athrv-ed.com, or you can DM us on Instagram or Facebook. We'll connect with you. So thank you guys. Have a happy learning. We'll also have further more sessions coming up in the future with the various different domains, not just in machine design. So we all hope to see you down there. We would like to have the same good amount of response that you have there. So spread the word amongst your friends also. This is a free learning that we are providing. So spread the word, connect with us. So we'll catch you up on the future sessions that we are going to have. Thank you. Have a good day.